Hello there, 7th grade. Welcome to section 716, also called Math Being Really Mean to You, but it's okay. We're going to walk through what happens when math does not throw you really nice equations to work with. So, let's say, for example, that you had this really nice sort of equation that is pretty simple and you've solved a bunch of these already. 2x plus 4 equals 10. Now, the idea is to let's get the letter x by itself, so I'm going to subtract 4. Look at that. Those numbers go away. I get 2x is equal to 6. And then you divide by 2, and it's all nice, and you get x equals 3. And then math is like, well, I didn't think they were having enough trouble with this. Let's give them a really fun problem, and let's put their favorite, let's turn everything into fractions. Now, I know that this looks like ugly and scary, and your first idea is to be like, ugh, I don't want to do this, this is dumb. However, I want to show you this trick because it's probably one of the most useful tips or tricks for solving these sorts of equations. You may not know this, but the world is not built in nice whole numbers. There's fractions everywhere. And so when you have problems like this, you have to start thinking, okay, what can I do to make this problem more simple? And in almost every case, what you're going to want to use is a process called a fraction buster. I know it sounds silly, okay, but you want to use this process called a fraction buster. Fraction buster. Now, what that does is it identifies a number that would let you get rid of or change these out of being fractions. So let's walk through this. I'm going to look at all three of these denominators and say, okay, well, there's a 3, there's a 3, there's a 3. Denominator is just a fancy way of saying that I have divided by 3. Okay, this is just another way of saying I have divided everything by 3. And I've done that in every one of these. So if you ask yourself, what is the opposite of dividing by 3? The answer is to multiply by 3. Now, what this means is you can multiply every part of this equation by 3. I multiply that by 3, I multiply that by 3, and I multiply that by 3. I know this looks like it's going to make it way worse and it's going to be awful, but bear with me for a second. If I multiply these, the trick to multiplying a whole number by a fraction is to just multiply the tops. 3 times 2x is 6x, and I'm going to keep the over 3 because it hasn't changed, plus something over 3 equals something over 3. Now, why did I make your numbers worse? You'll see in a second. And then 3 times 4 gives me 12, and 3 times 10 gives me 30. Okay, great. Well, I've just taken a hard problem and I've all of a sudden made it more complicated. But not really. The nice thing is that you got this. Now that you've multiplied by the denominator, I can look at this and say, okay, what is 6 divided by 3? Well, 6 divided by 3 is 2, so this is just a 2x. A little better. 12 divided by 3 is 4, and 30 divided by 3 is 10. And you may notice it is the exact same problem that we just solved over here, which is a lot easier to solve than this fraction monstrosity that we started with. The nice thing about this technique is you can use it all the time when there's fractions, and you can even use it when there's different values of fractions. So I want to take a look at this one here and say, okay, instinctively this problem, not easy to do, not fun to look at. There's no easy way to simplify this. Ask yourself, what number does 2, 3, and 6 go into? And you may recall this is called a least common multiple. Now, I know when the numbers are this simple, you don't have to do this. But counting out, oh, 2, 4, 6, well, hey, 2 goes into 6, that's great. 3, 6, hey, 3 goes into 6, and 6. So 6 is my least common multiple. And you can figure out, okay, well, let's try multiplying this whole thing by 6. It's my least common multiple after all. 6 times 2 is going to give me a 12b over 3. And I'm going to keep, again, I'm going to keep the original denominators here. I know that there's shortcuts and there's ways to do this a little bit simpler. But I've found that students make a lot less mistakes if they go step by step to figure out each of these pieces. So I've multiplied 6 to everything across the top. And now I start simplifying. 12 divided by 3 is 4b. Minus 6 divided by 6 is 1. 6b divided by 2 is 3b's. And then you figure, oh, I want to put my b's on the left side because that is the side that has more b's. So we're going to add 1 to the right so that we don't have to deal with it over here. I now have 4b is equal to 3b plus 1. Then I'm going to subtract the 3b away to get b is equal to 1. Now, this b equals 1 is a lot easier to, have as an answer than this mess of a problem that we started with. And that's basically fraction busters for you. It's a really easy process that can save you a whole lot of headache. I'd like you to go ahead and pause the video and try a couple of these. There's 3 of these on the screen right now. I would recommend pausing it and just writing them down and try a few of them. Identify your common multiple, multiply by that answer, and then simplify and try to solve it. It's very good practice, and once you do a few of these, it's going to be really easy. So I know I ask you to pause the video and nobody does, but go ahead and try it. Trust me, it will help. And now that you've pretended to pause the video and click play again, I'm going to look at this one and say, okay, well, you had 4 and 6. Those are your denominators. My least common multiple of 4 and 6 is going to be 12. If you're not sure why it's 12, you can just use 24 because that's 6 times 4. I multiply everything by 12. Okay, this is 12x over 4 minus 60 over 6 equals 84. And then, yes, you still have to multiply this over here even though it didn't have a fraction. You have to do it to everything. This gives you 3x minus 10 is equal to 84. And now you are solving a much simpler expression. Add the 10. I have 3x is equal to 94. And then I can divide everything by 3. And I know that's not going to give you a nice even number. So for the rest of these, I'd like you to try this. This first one is going to be 12 again. This next one will be 24 that you'll multiply by. And this last one has 9, 15, 5, and 3. And that one's going to be a little bit tougher, but I want you to do that by multiplying everything by 45. That's going to be the least common multiple for those. Now, I'm going to jump into talking about the homework for this. 7-70 is going to be one of these fraction busters problems. I will tell you that the first thing you should multiply by on this is 2, 5, and 10. Okay, least common multiple would be 10, so I multiply it all by 10. That leaves me with 30 over 2 plus 20x over 5 equals 70 over 10. Everything should now turn into nice whole numbers. 30 divided by 2 is 15. 20 divided by 5 is 4 with the x equals to 7. And now you solve that. Subtract the 15 and then divide by 4. This one you're going to want to find the least common multiple between 5 and 6, which is 30. Okay. On 7-71, you're going to solve the equation. There's a few different ways you can do these. With part B, you could actually do a fraction buster on that one by multiplying both sides by 21, or you can just divide away the 2/7, or the negative 2/7, excuse me. Part C is again a fraction buster that will work for this. You times everything by 15. 7-72 is going to be a 5D process, but now that we've sort of solved equations, what we can do is we can actually start making this a little bit easier. We don't have to go through the full guess and check process that is the 5D process. I know that the total was 43 because it says Trina planted 43 plants in her garden last week. So I'm going to start with 43 equals. And then you start reading it. You say, okay, she planted twice as many cucumbers as zucchini. Okay, well that just means that 2 times the cucumbers is equal to the zucchini. All right, that's interesting. Oh, I'm sorry. Twice as many cucumbers as zucchini means that the cucumbers is equal to 2 times the zucchini. Apologies. And it says that she planted 8 more tomatoes than cucumbers. She planted 8 more tomatoes than cucumbers. So the tomatoes is equal to 8 plus the number of cucumbers. And you're like, Okay, so I know that 43 is a combination of tomatoes and cucumbers and zucchini. All 3 of those things are together, and then your goal is to try and figure out a way to relate all 3 of those things together. So I know that the tomatoes could be written as 8 plus C, so I can put that there. Plus the cucumbers, I don't need that actually, let's just put 8 plus C here. Plus the cucumbers, and then I know that Z, well this is 2Z is equal to C, that's kind of weird. So you can flip it and write it as C divided by 2 because it's half of the cucumbers. And this equals to 43, and guess what? You have another fraction buster you can use. You just times everything in here by 2. Okay, you will quickly find that a lot more problems than expected have that fraction buster process. 7-73 is something that you've done a lot of. Your idea is to find the value that makes it the same across each tick mark. So if I'm going on the first one and it says there are 3 tick marks between 0 and 60, so 0, 1, 2, 3. If I did 60 divided by 3 and get 20, that means that this is 20, that's 40, that's 60, that makes this 80, and so on. So count the number of steps, 1, 2, 3, 4, 1, 2, 3, 4 steps, 60 divided by 4 to find each space. Okay. 7-74 is going to ask you to find the interquartile range of the data. That just means you take the 3rd quartile, which is listed as 80 here. That is the line right here on your box and whisker plot. 80 is your upper quartile, and 62 is your lower quartile, so your interquartile range is just 80 minus 62. Okay. On part B, it's going to be weird because it's going to ask you to take the original data that was given and add 55 and 67 to it. If you include those points of data, it's going to change all of these. So what you're going to do is you're going to list out all of those new points of data, have 55 and 67, and then make a new box plot. And your box plot should have 5 different locations on it. It should have a minimum, it should have a maximum, that would be the minimum and the maximum right there, minimum and maximum. It should have your first quartile, which is also named the lower quartile, which would be this line right there. It has your upper quartile, or your 3rd quartile, which would be that one, first quartile, 3rd quartile, and then here is your median. So no matter what, you're going to have a box and some whiskers, hence it being called a box and whisker plot by some, and there are 1, 2, 3, 4, 5 numbers that you care about. 1, 2, 3, 4, 5 numbers that you care about. Okay. And on 7-75, it's asking you to create a stem and leaf plot for the data and then a histogram. If you do this on your own paper and aren't able to write it in there, just tell me the shape and spread of the data and if there are any outliers. So if there are any numbers that show up in a weird spot. If there are no outliers, find the typical age by doing the mean. That's all I got for you on this one, 7th grade. Best of luck.